Conductivity electrodes must be calibrated with the instrument the very first time you will use it to take a measurement. They should also be recalibrated when you suspect the sensor may be out of calibration or on a periodic basis to verify that your calibration remains accurate. I'm Joe Ewak with Sensorex. Join me as we learn how to calibrate a conductivity sensor. To calibrate, connect your conductivity sensor to the instrument. If you have temperature sensor leads, connect these to the instrument as well. Follow the user instructions for connecting the wire leads and calibration of the sensor in the owner manual of your instrument. Most instruments will require that you select a range of measurement. Use the setup menu as shown in the user instructions. To calibrate, you will need one or two conductivity calibration standards. Sensorex offers a wide range of conductivity solutions that are traceable to NIST standards. Most industrial users will select a mixed salt standard. These mixed salt standards are designed to closely resemble real water samples that you're likely to encounter in the field. They will allow you to convert microsiemens conductivity units to parts per million of salt with reasonable certainty. For best results, select the conductivity standard solution that is close to the sample value you expect to measure. If you'll measure over a large range, select a standard that's about 65% of your full-scale range. For our example today, we will perform a single-point calibration. Place the conductivity sensor into a container of clean rinse water. Use deionized water or distilled water if it's available for critical applications. Remove the sensor from the rinse water and rinse it with a small amount of the conductivity standard for best results. Place the sensor into a beaker of the conductivity standard solution. Today I'll be using a solution of 731 microsiemens. This is a mixed salt solution and it has 500 parts per million total dissolved solids. I'm swirling the sensor around in the beaker to remove entrained air bubbles and ensure a proper and stable reading. We have to wait a minute or two for the reading to stabilize. Okay. Most users will be using automatic temperature compensation during conductivity measurement. Verify that the temperature reading of your sample by using a thermometer in the test beaker. I've already tested the temperature of these beakers and my accuracy of temperature is well within 1 degree Celsius. If you're more than about 2 degrees Celsius, you'll want to perform temperature recalibration as described in your user's manual. If you do not use automatic temperature compensation, you should select the manual temperature compensation mode from the setup menu in your instrument and put the actual temperature you are using in the calibration standard. To perform the conductivity calibration, we press the calibration key to enter calibration mode. The display will flash for a minute until it stabilizes. Use the arrow up and down if necessary to confirm the calibration value and return to the measurement mode. It's a good idea to check your calibration using a second conductivity standard. In today's example, I've selected a second standard that has a conductivity of about twice my calibration standard. I'll be going from 731 microsiemens into a standard that has a conductivity of 1,417 microsiemens. The 1417 microsiemen solution has a total dissolved solids of 1,000 parts per million. Again, stirring the solution to provide stable readings. Okay, my meter has stabilized. I'm reading 1,419 microsiemens. The standard that it's in is reading 1417, so it has very excellent agreement. Visit Sensorex.com for more information about the interesting products and accessories offered by Sensorex. Complete product instructions for all sensors may be found in the support section. They will show you how to properly calibrate, effectively clean, and the right way to use your sensors to obtain reliable, accurate, and repeatable readings. Thank you for joining me today for this brief presentation.